Hello everyone, this is Zephyr, or you can call me Raza, and how are you guys doing today? We have a pretty complicated problem today, and this is a pretty tough one. So this is 15 threesome from LeetCode, and this one is actually pretty tough to do the right way. So I'm going to go through this with you. First, I'll go through the brute force way, and then I'll go through the correct more optimized way. But don't worry if you don't get it first time. This can be a little bit tricky, but hopefully we can get through this, and by the end you will definitely have a good understanding of this. So I'll go through this slow. So imagine we have an array like this one here, which is -1, -1, 0, 1, 2, -4, -2, -3, 3, 0, 4. Okay, we have this array here, and we can actually create multiple pairs of 3, and we could have like multiple representations which would give us the sum of 0. So we wanna get a sum of 0 using these numbers here. So one way could be like using -1, -1, and +2. Okay, so this would give us -2 + 2, and this would give us 0. So this is a good weather representation. One other could be -1, 0, 1. So this would give us -1 + 0, 1, and this would be 12. So both of these are actually valid representations, and there would be a lot more for this case here. But the thing is that they have added some conditions to it. So let's just go through this problem. Given an integer array nums, return all triplets such that I is not equal to j, I is not equal to k, and j is not equal to k. So what they pretty much mean here is that we cannot use the same item again. So we cannot same number again, same item, and also we cannot have duplicates of same result. So for example, for this one right here, if we not this one actually, for this one right here, if we pick -1, 0, and 1, so we pick this one, and this one, in the next loop we could actually end up picking this one and this one and this one again. So this would make a duplicate of this, and that is not accepted by the LeetCode problem here. They do not accept any duplicates happening, so we have to take these out, and that's where this problem actually becomes complicated. Because if you were actually doing it through a brute force, so we were going to do it using a brute force approach of loops, we would actually run into this problem of duplicates occurring. So we could use like 3 loops here, and that would cause us to run into this problem, and this solution would be actually NQ. So actually, if you are going to do it using brute force, then you know that we will create like 3 variables, I for I, and we'll go to the length of n, then we'll go for j, which is j plus I, and we'll go length of n again, and for k we'll do k plus j, go to the length n again, and that would be your n cube of answer, which is not good. You can try it on your own, try to make it a brute force approach, but this is not going to hold in an interview, and they will actually ask you to do it another way, and also the LeetCode will not accept your answer if this is a brute force one. So let's do it the better way. Okay, so the better way of actually solving this problem is to first of all sort this array out. So if you remember to some 2 sorted array, up here you can check out the link, but let's do it in a more optimized way now. So we have we need to actually sort this out first. So we'll sort this one out, and this sorted would become 0, 1, 2, 3, and now we can actually use our logic, which is to use pointers. So we'll use pointers, but we will also do one more thing, is that we'll go through this entire array once. So we'll create a for loop that goes through this entire array once for I till length n. Actually, let's just say numbers have a pointer p1, and we'll have a pointer here p2. So at first iteration we'll pick -4, and we'll sum it with my 3 and 4. This would give us -3, which is not 0. When this is not 0, we'll check if -3 is greater or less than 0. We can actually see that -3 is actually less than 0, so we know that we have to increment this pointer by 1. So let's increment this pointer by 1. So at the second interval, we go 4, 2, 4, 4, -2. This is have to increment pointer 1 here, and in here we still have to increment. So let's increment pointer 1 again, and we are at this position now, and we say pointer, let's call it C for current, right? So we take -4, -1. Another iteration would be this one, and funny thing about this is that this will give us the same answer. We will actually go through this, but let's just skip it because we know that it will give us the same thing, and we are going to skip that. And for this we have 4 plus 0, we actually 0. So when we have a 0, we've actually found one pair that can be considered one of the answers, and then we will actually push it into our answers list. We'll have 4, 0. All right, we did a pretty basic one. Now let's just move a couple of steps ahead. So I'm going to show an example where we are actually going to get some duplicates. So I'm going to make my current at this position, and I'm going to start my pointer from here, and let's see what happens here. So at first iteration, or let's just speed this up a bit. I'm sure you guys understand the concept of the simple scenario here. So we take -1, we take -1 again for the pointer 1, and we take +4. This gives us 2, I believe, and this would make us go back a bit. So we will move P2 back, and when we move P2 back, this will become -1, this will remain -1, and this will become +3. So let me just move the P2 back as well. So our P2 is this now 3, which will give us a value of 1. So we'll get 1 here. This is not 0 still, so we have to move our P2 back because it is greater than 0. So let's move it back, and now we have 3 iterations. It will be same, and we'll get value 0, which is what we wanted. And when this is the same, we can actually add this combination here, and this will be one of our answers, but we will still need to go more forward. So what we can do is that when we have found it, we can actually just increment our pointer 1 because we found the combination for this. So we have to increment our pointer. Let's move it here. Okay, so once we have moved our pointer there, we will actually get values of -1, which is our current pointer, and then we'll get 0, and then we'll get +2 because we have not moved our second pointer, and this would be 1. So you can tell that we actually have to decrement our pointer 2 again. So let's just decrement our pointer 2, which will be, let's just go up a bit, and let's move our pointer 2 from there to there. It's a pointer 2 now, and this would be 0 plus, so now we have x0 value, which is same, so we can actually add this to here as well. Okay, so we have this error, right? And I'm going to skip some steps because we'll actually have to do this again. So we'll have to move our pointer again to this place. Okay, so we'll be having pointer 1 at this space, and then we'll do the same thing again, but we will not find any matches because you can see that P2 is right here and P1 is right here. And also we will skip this. We will also skip 0 again for this pointer because the previous value was the same. So we will never ever consider two same values happening together because that would give us basically same combination. So we will actually, let's just see what will happen if we take this pointer, right? So we took this pointer, right? And if we do take this pointer, so this is like a x6, so this should not happen. We need to take care of this. So when we take that pointer as well, so -1 is still the -1, we take 0 again, and we take 1 again, all right? Because our pointer 1 is at 0, this one, and our P2 is at this one. So this is the combination we're getting, and it's going to be this again, and this is completely wrong. Don't want this, because when we have this, then we might end up adding this duplicated array into our results, and this is not what we want. So that's why we will have to put some conditions in place, and one of them being that we will never consider any currents if there is a similar value behind this value. So for example, if I was at this position, right, and I have the current here, and I will skip this if this value exists here as well. So if -1 is exist here too, then I will skip this. And similarly, if this exists here, then I will just move my C ahead, and I will not consider this. So we will have C moved and it will be over here. And similarly, same thing goes for P1, pointer 1. Whenever I find a value which is similar to a previous value, I will just skip it. I will not consider it, and I will increment my P1 again. So I will plus it, and it would be at this position, okay, whatever this position is. The point is to skip it if the value exists previously, right? So that's the main point and main goal of this, and sorting actually helped us with figuring out if the similar value is present. So get ready guys, this is a bit complicated, and I'm going to share my screen for the code now. Okay guys, let's solve this 3-sum problem in the LeetCode editor, and I'm using JavaScript for this. So first of all, we are going to create a current index, and then we'll create an answers array which will hold all of our answers, and we will also have to sort this nums array. So let's sort it out using the inbuilt JavaScript function. And remember guys, you can actually use sorting and helper functions if the program doesn't actually require you to implement the sort thing, and you can ask your interviewer that, or let them know that you're just going to use a sorting function and focus on the problem at hand. And we can actually use the inbuilt sorting function and say that let's sort this into increasing order, and then we can create a loop which we will go through all the items of the nums array. So let's say let item nums, and then we have to do the condition here, which is we have the current. So let's see if current is greater than 0, and we see if the previous element was actually the same as the current element. So if item is equals to nums current -1, then that means that we have similar items back to back. So this would be that our C is right over here, and we will check if it matches this or not. If this matches, if the value is same, then we'll just skip it and go to this item instead, okay? And so that's what we're doing here. We're going to go current +1, and we will use continue. As in JavaScript, this will skip our current iteration and go to the next iteration. Once we're done that, let's create 2 pointers here. The left pointers will start from current +1. So whatever the item is after the current item, so it would be in this case it would be this, in this case this, okay? So we created a current +1, then we create a right pointer which is nums.length -1, so it is at the end. Then we create a while loop that will run until our left pointer is less than right, okay? As soon as it becomes equal or more than our right, it will stop. Let's sum it to first. So let sum is equals to item plus nums left plus nums right, and we do sum is greater than 0. So that would mean like sum is something 2, 3. Then we actually have to go back a bit. So we will decrement the right pointer here. Else if our sum is less than, then we'll increment left pointer. Else this means if this is equal, the sum is equal to 0, then we have actually found one of the answer, and we can actually append it or push it into our answers array. Okay, so we have pushed our item to the answers array, and as you can remember from this example, that once we found one of our array, we actually had to go down more. So for that we incremented our left pointer. When there was a comparison success, we incremented our left pointer, so we went ahead. So let's increment our left pointer here, and no need to change our right pointer at all. But we also have to check if when incrementing our left pointer is this value. Let me just clean. We also have to check if we are at this position. If we incremented our left pointer, then if this same as this one, then we will skip consider it, because if we do consider it, then we will run into this duplication problem. So Let's make that happen. Let's create a while loop and see if nums left is equal to nums left minus 1. So that would mean keep going until it's not equal to it, and we will increment our left by 1 if a is the same as the previous one. Also, we have to check one more thing here, that our left pointer does not actually go beyond our right, or it's not equal to our right. So we will do one here with my text. So we are pretty much done here. We have to increment our current as long. Let's increment that, and then we can end this by returning the answers. And so let's see, it passes our test. Right, so it passed our simpler test, and hopefully we will also pass our more complicated tests. I think there are like 312 or something. So we passed all of our tests, and you can see that this is actually a pretty hard question. So if you guys didn't get it the first time, I really encourage you to go through this video again, because I had trouble solving this the best way, and also I had trouble solving it entirely. So you can see that I actually fail sometimes. So I would really suggest that if you don't get it, do not be disheartened and go through this problem again. I am sure you will crush it and remember it once you have understood the logic behind it. Hopefully you guys enjoyed it, and I will see you guys with some other challenges later on. Take care of yourself. Bye bye. See ya.